Hello people, welcome one and all to Jojo's Learning Club.
Hello, what's up everyone? So this is the continuation video for the chapter 2 relations and functions on NCERT class 11th chapter 2 relations and functions. So today we'll be discussing on the exercise 2.1. So if you have any doubts on the theoretical explanation for this part, please refer to my card on the top, which will lead you to another video on the theoretical explanation for the exercise 2.1 and on the further exercises. Okay, so let's directly start with the first problem. The first problem is if x by 3 plus 1 comma y minus 2 by 3 is equal to 5 by 3 comma 1 by 3, find the values of x and y. So in relations and functions, you have already learned that is two ordered pairs are said to be equal only if the corresponding first element is equal to the first element in the second pair, and also the second element is equal to the second element in the second pair. So two ordered pairs are said to be equal only if the first and the second elements corresponding are also equal. So that what we can write, we can say that x by 3 plus 1 is equal to 5 by 3, right? So we can equate this and find easily the value of x. So let's equate it. X by 3 is equal to 5 by 3 minus 1. So x is equal to 2. X by 3 is equal to 2 by 3. So x is equal to 2. So we found the value of x. Now let's find the value of y. Y minus 2 by 3 is equal to 1 by 3. So how can you write it again? Y is equal to 2 by 3 plus 1 by 3, which is equal to 3 by 3, and that is equal to 1. So the value of x is what? Value of x is 2 and the value of y is 1. So that's for the first problem. And now let's directly go to the second problem. If the set A has 3 elements and the set B has given by 3, 4, 5, then find the number of elements in N in A cross B. What is this A cross B? A cross B is what? This is the set of all ordered pairs. That is the Cartesian product of a set is given as A cross B. So you know from the Cartesian products that the number of elements of the Cartesian product or the number of elements of A cross B is what? N of A into N of B. So it is already said in the question that the set A has 3 elements. So what is it? N of A is equal to 3. And the set B is also given. What is it is given? There are 3 elements in it, 3, 4, 5, right? So from that you can easily find that the number of elements of B. What is it? It is equal to 3. So what is N of A cross B then? The number of elements in A cross B is what? Number of elements of A into number of elements of B. That is 3 into 3, which is equal to 9. So there are 9 elements in A cross B. Okay, so that's all for the second question. And now let's directly do the third question. If G is equal to 7, 8 and H is equal to 5, 4, 2, find G cross H and H cross G. So what it is, we have to find the set of all ordered pairs. So G cross H, how you will find that? You already know that if X, Y are elements of A cross B, then A cross B is given by set of all ordered pairs X, Y, where X belongs to A and Y belongs to B, right? Similarly, you can write G cross H as what? G cross H is equal to, so what are the possible relations? 7 and 5. So you can write 7 comma 5 as one ordered pair. The next ordered pair would be 7 comma 4. The next would be 7 comma 2. Again with 8, set of all ordered pairs is the Cartesian product of sets. So you have to find next with 8. So what are the next set? 8, 5, 8, 4, and the next one 8 comma 2. So these are the set of all ordered pairs of G cross H, or the Cartesian product of G and H. Next let's find the H cross G. What is H cross G? So the set of all ordered pairs of elements of H and G. So the first element should be 5, right? So 5, the possible relations are with 7 and 8. So you write first with 5 comma 7. The next possible relation is what? 5 comma 8. Then next one 4 comma 7. The next would be 4 comma 8, and the next one would be 2 and 7 and 2 and 8. So now we have found the answer for the problem number 3. I hope it's clear. Now let's directly move to the fourth problem. State whether each of the following statements are true or false. If the statement is false, rewrite the statements correctly. So let's directly read the first problem. There are 3 problems, right? Okay, so if P is equal to M and N and Q is equal to N and M, then P cross Q is equal to M comma N and N and M, right? That is what given in the question. So now let's directly find what is P cross Q. P cross Q is what? Set of all ordered pairs of P and Q, right? So what are the possible relations? M and comma N, then what is the next one? M and M, again N and again N and M. So there are four number of ordered pairs and it is given only 2 over here. So what can you say? It is a false statement. Okay, now let's go to the second section of it. If A and B are non-empty sets, then A cross B is a non-empty set of ordered pair X, Y such that X belongs to A and Y belongs to B. Is it true or false? It is true, right? It is said about the Cartesian products. So Cartesian product of set is the set of all ordered pairs of A and B, where A and B are 2 non-empty sets. So it is a true statement. True statement. Now let's go to the third section of this one. If A is equal to 1, 2 and B is equal to 3, 4, then A cross B intersection 5 is equal to 5. So for that, first you have to find what is B intersection 5. B intersection 5 is what? Again, it's a empty set, because when you take common set between B and 5, 5 is already an empty set. So there is nothing to take common and it is already a 5. So A cross 5, you can find a relation with an empty set. So again it is a 5 and hence it is a true statement. I hope it's clear. Now let's directly move to the fifth problem. If A is equal to minus 1, 1, find A cross A. So what is this set actually? It is actually a ordered triplet. So this is an ordered triplet. So this also we have learned while learning about the definition for the Cartesian products. So what is A cross A? For example, A cross A, you can represent it as set of all elements A, B, C, where A, B, C belongs to A. So you can directly find what is A cross A. So what is it? Set of all elements. How many elements would be there? So 2 into 2 into 2. That is total number of 8 elements are possible. So what are the set of all ordered pairs? You can write it first from minus 1, minus 1, minus 1. The next one minus 1, minus 1, 1. And the next one minus 1, 1, minus 1. And the next one minus 1, 1, 1, and the next one 1, minus 1, minus 1, and the next one 1, minus 1, 1, and the next one 1, 1, minus 1, and the last one 1, 1, 1. I hope it's clear. So this is the set of all ordered pairs for a ordered triplet. I hope it's clear. So that's all for the today's video. We have discussed the work problems from 1 to 5 for the exercise 2.1, and on my next video we'll be discussing the further work problems, that is from the problem number 6 to 10 on my next video. So let's see you on my next video. Bye bye. See you then.